Welcome to fourth lecture on two-port networks. In this lecture we are going to discuss about symmetrical and asymmetrical network. First we'll start about symmetrical network. What is a symmetrical network? Symmetrical network is a network whose electrical properties won't change even if we are interchanging the input and output. So we can easily interchange input and output ports. We can connect output at input side and input at output side and vice versa. The electrical properties won't change. So then what is asymmetrical network? Asymmetrical network is a network which is not symmetrical. That means the electrical properties will change if we change the input and output ports. Similar to symmetrical network, there is another kind of network called reciprocal network. We'll discuss about symmetrical and reciprocal network and the condition for symmetry and reciprocity for the network in terms of network parameters. So what is the condition for symmetry in terms of network parameters? So condition for symmetry with respect to network parameters, we learned 5 network parameters. With respect to all these network parameters, we'll derive the condition for symmetry and reciprocity. Will not derive, we'll just give the expressions. The derivation also it is very simple. We will not go through the derivations, just we'll give the expression for symmetry. In terms of Z parameters, if Z11 is equal to Z22, then it is a symmetrical network. In terms of Y parameters, Y11 is equal to Y22, then it is a symmetrical network. In terms of ABCD parameters, A should be equal to D. In terms of H parameters, the determinant of the matrix H11, H12, H21, H22, this should be equal to 1. Same applicable for G. For G also we have to write like this, G11, G12, and for simplicity I am writing determinant of G should be equal to 1. This is the condition for symmetry. So also we told there is a other kind of network called a reciprocal network. So condition for reciprocity or condition for reciprocal network. This is similarly what we written for symmetrical network. Similarly for all parameters for Z, Y, A, B, C, D, H and G. With respect to all these parameters, we have to write the condition. With respect to Z parameters, Z12 should be equal to Z21, and with respect to Y parameters, Y12 should be equal to Y21. You can see here always Z and Y always follows the same pattern. With respect to ABCD parameter, the determinant of ABCD should be equal to 1. And with respect to H parameters, H12 should be equal to minus H21. And with respect to G parameter, G12 should be equal to minus G21. These are the condition for reciprocity. So condition for reciprocal network and symmetrical network we defined here. Next we'll go to the detailed analysis of some kind of symmetrical and asymmetrical network. There are popular symmetrical and asymmetrical network. For symmetrical network, popular symmetrical networks are, one is T network, then pi network. We'll go details about this network in upcoming lecture. For asymmetrical network, we have asymmetrical T network, Also we have asymmetrical pi network. If we are changing the pi network elements, it will become asymmetrical, but we will not discuss about asymmetrical pi network. Instead we will discuss about asymmetrical L network. So in our upcoming lectures we will be discussing these four. In T network we will be discussing for symmetrical networks what are the properties we know, characteristics impedance and propagation constant. So we'll derive the expression, or at least we'll write the expression for characteristic impedance and propagation constant. Similarly for pi network as well, we'll derive the expression for, or we'll at least write the expression for characteristic impedance and propagation constant. Similarly for asymmetrical network, we know the parameters are iterative impedance, then image impedance. All these things we'll discuss in upcoming lecture. Thank you.